All right, let's get things started. Good afternoon, everybody. My name is Neil DeMazier. I'm the Vice President of Sales and Marketing here at Imagine. This is Imagine Academy Quarantine Sessions number 9. This is actually the second in a two-part series all about digital implant design, case design with exocad, 3D printing with the NextDent 5100, and a bunch of other things that go along with all that stuff. So if you joined us yesterday, you know we had a couple of technical difficulties, and it's looking like things are going to go much more smoothly today. So we're looking forward to doing some really cool stuff. Before I introduce my guest today, I'm just going to do a little bit of housekeeping here. If you could, please keep your microphones and your video off throughout the duration of the presentation today. That just allows us to keep the focus on the presenters. If you have any questions throughout the webinar today, by all means, ask them. You can use the chat function down here towards the bottom of the screen. Send over any questions or suggestions or comments throughout the presentation today, and we'll keep an eye on that and be sure to mention those to the speaker when an opportune moment presents itself. So aside from that, if you want to catch up on any previous quarantine sessions that we've done in the past, we're posting all of these to our YouTube channel, so you can find that very easily. And then also, if you want to find out any more information about any of the products we're using today, whether it's ExoPlan, the DentalCAD product from exocad, the 3D face scanning product from DOF, or of course the NextDent 5100 3D printer, you can find all of that at our website, which is imagineusa.com. So without any further ado, I'm going to introduce our guest today. We have Matt Kennedy. He's the owner of Creative Restorations Dental Lab down in the great state of Florida. He's going to be presenting first today. But we also have Dave Carballeyra from exocad America. He's one of the exocad gurus over there and might be answering some questions in the chat room or maybe hopping on to demonstrate something for us real quick here at some point. And then last but far from least, we've got Adrienne Slevin from 3D Systems, makers of the NextDent product. Hey, Adrienne. She's going to be showing off a lot of super slick prints that she did to support the case that Matt's designing today. Wide variety of things. So we're going to start off with Matt. He's going to walk us through some of the case design for a full arch reconstruction. And then Adrienne's going to be going through the printing aspect. And then we're going to hand it back to Matt to talk about aesthetic finishing of some of these printed appliances. So all that being said, Matt, why don't you go ahead and turn on your microphone and your video, and we'll get things started here. There he is. Take it away, Matt.
All right. Good afternoon, everybody. Good morning to the West Coast. Matthew Kennedy here. I want to apologize for yesterday's computer issues. Apparently, my computer got this virus that's going around, but it is all now resolved, and we took our hydrochloroquine and our Z-Pack, and I think the computer is good to go. So today we don't have a lot of time. So what I'm going to do is start off with figuring out how to shrink you real quick. And here we go. We move you guys over here. Okay, so we're starting out with a full arch. The patient actually has almost all their teeth. Let me show you the jaw that we're going to be working with real quick. So you can see how it was modified. So hopefully you guys can see this. All right, so obviously all the teeth are here. So what I did with this case, knowing that I'm going to do 4 implants, 3, 6, 11, 14, I went ahead and modified this to do a tooth supported surgical guide. And you'll get to see that here in a second. So we're going to go ahead into the implant planning, and I'm going to cruise through this because of time so that we can get to the actual final design to show the workflow of how easy things can happen through here. So and I may have just opened the wrong one. Meshes. Oh, I'm sorry, guys. I'm trying to give you guys the wrong one. Let's do this. Try it one more time. That virus again. Okay, so I'm going to go ahead and load in the modified jaw scan, and then the lower jaw scan, and then it's going to ask for the CT data. That's going to be here. Click next. I'll show you guys in a minute how we modified the model. We'll be doing it when we get to the full design, so we can just save that part for there. CT is loaded. Axial and view direction is parallel, looking good. We're going to the next. Here, we're going to do the alignment. You can see here, I extracted the second molar, cuspid, second molar. We're going to leave the other teeth there for the 2 supported surgical guide. I usually switch this to the enamel for the alignment. We're going to go lateral, lateral. We'll go central, central, and then let's pick a molar over here. Here, 3-point alignment. We'll start the alignment and go to the best fit matching alignment. Blue means you're good. All the blue for the alignment is good. We're happy with that. We're going to accept it. We're going to click OK. And OK, that was just from previous. We're going to go ahead and define the panoramic curve. I'm going to just drop it here. Very simple process. We're not working with the lower, so we're not having to do the nerve today. That again is an easy process through exoplan. We're going to go ahead next. From here, because we're not changing the orientation of any of these teeth, the setup arrangement is going to be pretty much the same. We're going to put teeth on here, but we're not really going to go through the whole process of setting them up because we're going to do that in the final, and I'm going to actually switch libraries at that point. So from here, chain mode, I like to click the moves all simultaneously, and then you can kind of get it in a basic position. I'm not going to worry about this too much because we're not going to use these digital teeth for our design, but that'll just kind of put them in an ideal situation. So from here, we're going to select, let's go with Straumann today. Straumann, we'll do guided bone level. And we're just going to drop implants here. I like to get my CT off and go with my model. Being a lab tech is kind of what I'm used to. And then I'll use the slices on the right side of the screen to kind of help me with position. Now, the CT scan we have has a lot of scatter, and that's from restorations that are in the mouth. So sometimes it's a little difficult unless you have a really clean CT to do that. And I'm not going to get too technical about where I'm putting these implants. We're just going to get them in place and keep on cruising. That way we can just continue moving forward with the case. So here, I'm going to bump this up some, just give me some room. You can see I'm red. I'm interfering in the sinus cavity. We're going to just drop that down just a little bit. We're going to go ahead to the next, drop the next implant in. And while I'm doing these few implants, the way I'm doing them, let me just point out, before I ever got into the guided surgery, I was very worried about knowing how to read an x-ray. It was something that scared me, made me nervous. I didn't want to mess anything up. I didn't want something to happen with the patient and then, just bad stuff. So I went to my surgeons, I went to my dentist, I learned how to read x-rays, and I still every single day learn something new. So if you don't have exoplan and you're thinking about getting it, don't be afraid, ask the questions. There is never a dumb question. And again, some of you are going to be like, well, why did he put that implant there? We're just going through this right now just to get through it. We can do another class another day on implant placement and the things that we're looking for. But our whole goal today is to go ahead and get to this final restoration without it being too big of a deal. As a technician, and all you guys know, your crown and bridge guy, he knows, you know how to make a tooth. If you're a denture guy, you know where to put the tooth. Okay, well, once you become guided surgery, none of that changes. You still know where to put the teeth and how to make the teeth, but you have to explain to your doctors, let's base our implant placement off of where our restoration is going to be, not where the teeth are now, but where your final restoration is going to end up. If you approach your implants that way, a lot of things come of that. You'll know if a patient needs bone grafting. You'll know if a patient needs to have bone reduction. All kinds of different things come into play. So what we're going to do now is we're going to go ahead and get these guided cylinders in place. I like to be above the tissue a little bit. Right here, you'll see I'm in the tissue, and here we're going to modify this model some more here in a little bit, and then those will be up in air a little bit, if you would. So again, I'm going to call this okay. The sleeves here, we're using the fully guided sleeves from Straumann, 5mm for your guide pins. This is going to produce a report. Once you did your planning, you go to your doctor, you're going to email him this plan or have him team viewer with you so that you can go over the placement. And I highly recommend do not ever move on forward from here unless your surgeon, doctor, whoever's doing the implants have said, go for it. This is what we want. But always share the information. I'll do a quick show of the report real quick. I'm just going to scroll down, table of contents, DICOM information, pan with no implants, pan with your implants, your shopping list, then different angles showing your safety distances between certain elements, and then it'll go through slices to where the doctor can see the slices of, I think it's I don't know the thickness of the slices. Dave might be able to answer that on the thickness of slices that are shown. So that's kind of a idea of what you're going to get for a report. So from here, we are done with the implant placement. We're going to go ahead and go into the surgical guide, which is easy. Just go right into it. Your cylinders come up that are going to hold your guided surgery. We're going to make sure these cylinders are a little narrow so they're not really hitting the adjacent teeth. It'll make for an easier adaptation to your surgical guide. So here we have the sleeves in place. I like to do on my night guards, on my surgical guides, I do a 0.08 for the offset. That gives us a pretty good fit to our models without too many adjustments. So I always change that. We're going to do path of insertion, set our path of insertion, and go ahead to the next.
Off to a great start here, Matt. And just for anybody who's joined us since the beginning here, if you have any questions at all, we're kind of cruising through some of this because we reshuffled the schedule a bit, but we absolutely have time for your questions. So if you have any questions, submit them via the chat box towards the bottom there, and we'll be happy to answer them when we get a moment.
This takes a couple seconds, obviously. Okay, so from here, thickness, I always leave at 2.5. My smoothing, I do 1.5. Just kind of, that's a natural thing we do just from doing the TMJ splints, night guards, and things like that. That's just been kind of our happy settings. And from here, it's pretty simple. Just like you were doing a bite splint, you're going to give your parameter margin, if you would. I'll come around lingual to the tissue, come around, and then maybe I'll come up on the teeth some, a little bit, and back down, back up on the teeth. You can see the undercut, so you can tell if you're staying out of the undercut or not. Below your cylinders, not below your cylinders, below your cylinders. and we go double click, we'll attach all that. We're gonna go ahead and hit apply just so you guys can see instead of hitting the next button. So here's what you end up with for a start. You can always change this before you hit next if you want. We're gonna continue. That was saying a collision. That's just a normal thing that pops up where you can see your splint interfering inside of your cylinders. From here, if you want to put a window to confirm seat, you can do that. You know, put a window in here, and then that'll show the opening. You can put as many as you want, as little as you want, or however you want to do that. Next, we're going to go into the save. I think I got record time going on this one here. So here you are. There's your guide ready for your sleeves. From here, you can free form it. You can add, remove, smooth it, add some thickness if you want in places, things of that nature. It won't alter anything that you've already done except the thickness of anything around your cylinder areas. So from there, we're done. There's your surgical guide. And we will show a picture of that after we get through that Adrienne has printed for us, and we've got some sleeves in it. Here we're going to go next and done. So you're done. Simple as that. So you go, okay, well, now let's design the restoration. That's as simple as going into your regular exocad. You're going to load your actual exoplan project into your exocad. So we're going to load. We're going to go exocad project. That would be this one, project. From here. So now the one thing I have changed that you won't be able to see, these 3, 6, 11, and 14 would have come in here as implant planning. This at this point is where you change it. So I've changed these to an anatomic wax up, ponic wax ups are the blue, and then bridge everything together so it keeps it all as one piece. So we're going to go ahead and design from here. We're going to go ahead and import the implant planning information. That way it'll allow us to do tie bases, bar bottoms, direct to the implant. It doesn't matter. We always have those options with exocad, and options are great. Now remember, I didn't like my tooth arrangement. We're going to change that. So I'm going back to the original jaw and the lower jaw. Now, from here, this is going to be our scan data orientation. We're okay with that. Now, at this point, I'm going to go to expert mode. We're going to go ahead and add a couple images here. Let's add a face scan so we can see what this patient looks like. Load. And sometimes if we'll do a pre-design before we do the implant planning, so that we know if a patient's going to need bone augmentation or not. So from here, look at that mug. Oh my goodness, look at that mug. All right, so we're also going to go ahead on the image. We're going to edit mesh. We're going to open up the mouth. We learned something new the other day from Dave. He was going to come in here and click. And instead of closing this circle, we're going to get it pretty much where we want, and then come over here and hit delete, and that'll make a much cleaner removal of triangles. So again, look, Bluetooth, imagine that. So we're gonna go ahead and get rid of the shoulder. We don't need any of that. All right, so now we have his mug. So again, talking about bone augmentation, when you see the smile here, you can still see the tissue. We know that if this patient, myself, were a full arch candidate, we would definitely have to remove a lot of this bone in order for the transition line not to show when the patient smiles real big. So knowing that, let's do this. Let's go ahead and get rid of my big old head. We're gonna modify this upper jaw as well. So go ahead and get these off of here. So Dave has a new feature on the exo plan that's coming out. This is the old way that we had to extract teeth. I'll just come in here and circle them. And again, I'm just doing this kind of fast. We know that I have to have bone augmentation. So there's going to be a lot more to just extracting some teeth. So we're going to go ahead and hit delete. We're going to go ahead and close holes. You're going to just circle around everything you want to close. Close holes. Holes are closed. Now I'm going to go and right click on that image again, and we're going to freeform it. Oops, wrong button. Freeform scan data. We're going to get rid of our anatomic, get rid of our antagonist just to get out of the way. Now, knowing that I have to, got a little blip there. Going to need some bone augmentation. We're going to do this a little bit differently. And also, if you remember, I didn't have a lot of room for implants. So without a lot of room, when I go to remove some of this bone, those implants are going to be taller up than what we'd like them to be. But this again is just giving you guys kind of a basic idea. We're going to go ahead and shrink that. Let's bring the face up while we're doing that. Now, no more tissue. Okay. So we're going to say that's okay. Get rid of the face scan. Now we're going to go ahead and smooth this out. Holding the shift key will make it go a little faster. Cruise right on. There's one of the tops of one of our implants. Okay. So we can add some here if we wanted, just so it looks a little prettier. All right. Again, because we're in a hurry, you can fine tune this however you want. Go over with your surgeon how much tissue you plan on removing. Everybody agree on something, and then design accordingly. Okay, so now we have face scan, no transition line showing, tissues in place. We're going to say, okay, I'm going to go back to wizard mode. Virtual articulation, we're not going to be going over that today. It's a very easy process. We're just going to skip that and go to a basic arrangement. From here, this is where you can make the decision. You want a custom abutment, you want screw retained on a tie base. We'll go ahead and call it a tie base. We're going to be using missed scan flags. And then you can pick S-link, L-link, short, a tall, or having it directly to the interface here. The other good feature of this is with the S-link, with the opening, if you're going to do an angled screw channel, we have the ability to rotate that here. Whereas if you have your scanner scan it the wrong way, you can correct that now. That is a great feature to have to where you're not rescanning something so that your tie base isn't in the wrong position. So we're just going to do S-links across the board here. Keep it simple. And S-link, and we'll just go ahead to the next. Missed, use anyway. Oop. Go to next. Let me back this up some for you guys. Tie base. Missed, use anyway. Next. So even with my face scan here that we have, I'm not going to worry about emergence profiles because we don't actually have the implants in place there. I didn't like the setup we did in the beginning, obviously, because we weren't going by my actual setup. We were going by the original teeth that were on the model. So we're going to go ahead and load a custom model and get something that's a little bit easier or a little bit more like what my natural teeth look like in theory. So at this point you go, oh man, where were all your other teeth? We can also, which we'll do here, we're gonna add another mesh. Hold on one second, expert mode, add mesh. We're gonna add a pre-op. This will let me see where my teeth were. Now I have my original arrangement on here, and it'll be much easier to go through a tooth arrangement. So what I like to do for the tooth arrangement is I'll click move all simultaneously to where I can kind of get them where I want them. Let's do this. We'll leave it there. From here, we're gonna come up, get them somewhere close. I like using that chain mode. As a denture guy, I'm very used to getting my front two teeth where I want them. I'm able to check the width here with where I was and where I'm going. We can probably go a little bit wider. Very good. Get a basic tooth arrangement. Once I get that basic tooth arrangement, I'll uncheck the simultaneously, go into chain mode. I'll lock in my two front teeth, and it's not even Christmas. We'll go ahead and drag this where we want. And again, don't forget, you have the face scan image that can help. You get teeth where you want, lock them in place. That's a great feature to have so other teeth don't move. And again, we're just trying to blow through this real quick to get the gist of it. I also am missing one bicuspid. I would have changed this to 1 bi and 2 molars. On males, I like to do 1 bi, 2 molars. On females, I like to do 2 bis, 1 molar. But I'm gonna go with my feminine look today, and we're gonna see how that works out for us. So here we go. Got the face on there. You're looking. Let's move that up a little bit. Okay, somewhere around there. Get rid of this pre-op. So you get the gist of it. Use the face scan. It's out there. We've had it a while. We've been really happy with it. And it has allowed the patient to really see what they're going to look like before we've actually finished anything. So from here, we're going to leave that as a tooth arrangement. Actually, we're going to undo, yes. We're not going to have it or match the pre-op. We're just going to move forward from there. Here's where we can, if your screw channel is coming out and you want to angle that screw channel, maybe, where are you? Here we go. You're going to click clickable. And from here, you can angle that screw channel to a different spot if you're not happy with where it's coming out. We're going to leave it there. And on that S-link that was under that, we would have rotated that so that it was not in the way. It looks here, I still really need to reduce some of that tissue area there. So let's do that real quick. We're going to go expert, and we're just going to get it out of the way. Our freeform scan data, you're around here somewhere. Right here. We're going to ghost in our teeth so that we can see. We're going to go to remove. We're going to increase the strength. Let's just get it all out of the way. Now, even with all this bone reduction, you see doing a hybrid on me, there's still no interocclusal space in order to get a bar or zirconia or whatever. There's not a lot of space at all. So definitely not really a candidate for a full arch here. But we're going to pretend like I am.
And Matt, while you're getting that going, we had a quick question here from the audience of what was the face scanner that was used. So that was the DOF Snap face scanner, and you use it in conjunction with the DOF Freedom UHD, the ultra high definition desktop
Correct.
scanner. Is that right?
Correct. And I can tell you, I've tried a lot of face scanners. The benefit of the snap scan is alignment to close to real as possible, because it uses a bite registration in the patient's mouth, and then that is scanned in accordance to your model work. That really ensures that your alignment is what it is. And I've did Bellis, I've did one from Open Technologies. We've tried a few of them, and it really comes down to, is what you see what you get. And I've found with the snap, what you see is what you get, because of the process of aligning the face to the jaw scans. So that was a big reason why we made the investment and went forward with that. And I can tell you, there's nothing like seeing a patient see their face, and when you do the restoration on it and they see it, it's amazing. They get it. You're not handing them a stack of papers that says, oh, you need $30,000 worth of work. Take these home to your spouse, and you take a big old stack of papers home to your spouse, and then they're going, oh, I need $30,000 worth of work. Now, with exocad being able to send the files digitally, it allows the patients to have 3D images that they can show their spouse what they're going to look like. And that has been a huge advantage. Obviously, my anterior tooth setup looks like crap. So if you wanted to fix that, very easy. We're going to go in here and go to correct placement, and then I can grab these and move them into a better scenario. So again, it's never too late. You can always go back, go forward. It's a real easy flow. And then we're gonna stand this up a little bit. Again, let's slap that big old head on there. Hey, there he is. Don't like it. Don't like it. Don't like it. There we go. All right. So you guys get the gist of it. The other thing the face scan helps with, when we do our denture try-ins, if we have an image of the face, it really eliminates the having a cant to your setup. You know, we're used to working with models with no face. As soon as we get this face, it gives us so much more information. And that's really been key to this all being a success. I just think that the face has been a wonderful add-on to everything we do. So here, we're gonna go ahead and get rid of the antagonist. We're almost done. You can tighten these teeth up if you wanted. For today, we're not worried about it, even though it's bothering me a little bit. I'm still gonna move them. Here, we're gonna adapt the occlusion. I don't adapt to the Ponix until the very end. We can go ahead and do that. That'll adapt everything to the new model. And we're almost there, guys. Occlusion, 0. Adapt. Interproximals, adapt. And then from here. Now, if this is going to be a conversion patient, again, this is our path of insertion for our virtual wax up bottom. Again, I would do a 0.08 as a common for fit, whether it's a denture try-in, whether it's a surgical guide, whether anything that I know is going to a stone model, I use a 0.08 for that. So we're going to go ahead and click next. That's going to give us our wax up bottom. Now, like I was saying earlier, if this was going to be a conversion denture, what I like to do is I make two. I make an actual removable denture, and I also make a conversion denture. If we are not able to load those implants and get the torque that we need, then we need to deliver a removable appliance, and the patient's informed of that. And it's not a surprise sometimes. Sometimes we don't have the bone we need to get the torque we need. So here's where the first one I do is I go ahead and design my denture. So I do my base plate at 1.4. That'll leave me some about a half a millimeter for some pink, so that we can print a monolithic denture. And then my cervical thickness, again, I always do a 1.5 just out of habit. So from here, it's as simple as clicking where you want your denture. Click around the perimeter for your flanges. Double click to close it. And then we're going to look after this produces just to see where it falls on the face scan for the smile line. Okay, there's your gingiva. Not seeing gingiva, so that's always good. So from here, there's your denture. Okay, we're going to go ahead and now you can modify this gingiva, make it longer, shorter, and clean all that up. We're not going to go through that, but it's a very easy process. That's where you can do it here. Let me get rid of the pre-op. This is where you can freeform the gingiva and things of that nature. We're not going to do that. The connectors, if you have a base on it, you don't need the connectors. So we X, get rid of the connectors. There's no reason for them. The base is going to hold the teeth together. So right now we're going to go ahead and make the virtual wax up. It has an ugly tooth arrangement. Please ignore it. Could have been better, but we're pressed for time. So after this calculates the virtual wax up, I am going to go ahead and save that scene of the denture as an STL file, name it temp denture, put it in that patient's folder, and then I'm just going to hit the back button a couple clicks and then change my tissue design. And then from there, finish it out as a horseshoe denture that can be used for conversion. And then Adrienne, we have examples of that that we'll show of the conversion denture. This just takes a couple minutes. It's doing a lot of jobs right now, and it's having to think about it. Again, the big old noggin. You know, that's a great feature to have. And yes, I've always had a hole in my head. Even the tattoos show up. I mean, the scanner's awesome. You do have to play around with your lighting and control the ambient light. You don't want any direct light on it. And that just takes a little bit getting used to it, finding a place in your lab. You can even use, like we use a black curtain, like a box, and we leave the patient in the chair, stabilize the scanner, and we rotate the patient in the chair. We don't rotate the camera around the patient's head. We've gotten better results doing it that way versus moving the camera left to right, up and down, or however you got to move the camera. This probably wouldn't have taken so long had I had a much cleaner design or been pushing buttons while I'm trying to let it do its thing. Come on.
Hey Matt,
While
while
this
we're
is,
waiting for this to calculate here, does it make sense to have either Dave show off? I know there's a couple new features in the upcoming release of
yes,
ExoPlan on tooth extraction. Is that Dave? Is that something that you're prepared
that,
to show us real quick?
that'd be great.
Yeah, I can jump to that really quick.
Do I need to stop share?
Yeah, if you don't mind, stop sharing your screen, Matt.
Okay.
And Dave, you can take over there.
Okay. So this is one of the newest features in ExoPlan 3.0 with the codename Galway. And one of the nice features is you saw Matt how he had to manually extract the teeth, close the holes. This is now going to be very automated, and you can actually preserve the existing data as either a wax up or a pre-op object type in exocad. So to demonstrate, I'll just go ahead and click on this canine here. You can see how the software automatically detects that boundary there at the gingiva. Then we can simply select the tooth number that it belongs to. Now, if I hide this, you'll see that it's a very precise cut. So it cuts that tooth form and then also closes the underlying mesh. You can see that there's some sharp edges here, so you could certainly go back and do the freeform scan like Matt demonstrated earlier. And you know, for example, if you just wanted to remove these anterior teeth, you can just extract another and make your selection again.
Love
But
that.
very quick process, and so far our testing has shown that it's very consistent, no matter what that tooth looks like. All right.
Good. I should be good now.
Yep. Back to you, Matt.
All right. And share screen. Share. Okay. So it's calculated. Here is our denture. We're going to get rid of the screw channels, the abutments, minimal thickness. I get rid of everything except the denture itself. So here's your denture. Okay. And then what I'll do, oh, there's still some things hiding. So from here, I'll right click on the screen, save scene. We're going to save it as a STL file. We're going to call it a temp denture. So there, you've got your temp denture made. So now you've got a backup in case the implants aren't integrated enough or torqued enough. So now I'm actually going to go back 3 steps. 1, 2, 3. We're going to clear that gingiva design, and we're going to do it again, except this time I'm going to do it as a horseshoe scenario. And again, maybe after, while this is calculating, if Adrienne wants to talk about some of the printing, I have some of the stuff she sent me over here. We can do that while this does the same thing it just did a minute ago.
Sounds like a good plan, yeah.
All right, let me get it to the next couple steps. And again, normally we would have more space between the teeth and the tissue, except obviously I don't have enough bone to do that with without having to do a sinus lift or things of that nature. But this will definitely kind of give people the gist of it. We don't need the connectors. Go to next. All right. All right, that is generating. Adrienne, if you want to take over, I will stop share. All right. And
Okay, I'm sharing now.
hey, look at that head.
Hey, well, I'm just making up myself a little planter right now. You guys interrupted me. So I'm gonna go ahead and nest and send these to the printer, start the printer, and then I'll come back to you.
All right.
So I'm not gonna nest this right now. I already did that, but I don't have it completely printed yet. I'm gonna grow some plants and see what you'd look like with hair.
That's it's been a lot of years. I use that head as my brush holder. So,
That's awesome. Okay, so the first thing that you're going to do, if you have an extant printer, this is how you'll set it up. The same rules apply if you're just using an extant resin with your own printer. So you're not stuck with an extant 5100 if you have already made a decision on a different printer, no big deal. We're going to nest everything that Matt has designed and is designing. So instead of showing you model nesting, which is pretty straightforward, I'm going to go ahead and show you nesting the provisionals. So we'll hit next, and we'll just choose our Crown and Bridge MFH, and I'll go over a couple of things about the indications you can use that for. It's a very broad material, awesome properties, and quite a few shades, as you can see. And we'll use bleach, America's favorite. Next, and we'll hit set. Then we're just going to pull in those files that he has designed. And we'll go into our temps and pull all of these. Now, we did miss a couple of designs that he was planning on doing yesterday, and that was 2 screw retained crowns as well. But I'm going to go ahead and nest those anyway so you can get an idea of it. So the first thing that I always do is hit auto place. And we change these to 0. We want the auto placement to work as well as possible, and just to cram everything in there as close together as it can. And if you do Z-axis rotation, it will allow you to, it'll actually rotate some things for you. Now, a couple of tips to get auto placement to work even better is if you do have exocad, which let me see if I can share this as well. Can you see my exocad screen? No.
Nope.
Let me share something. So if you have Matera or later for exocad, and you have 3D Sprint, which is the nesting software I'm using, you'll actually have the material configuration here for your NextNet printer. And you can even use that for your other printer with some of the NextNet materials, because your minimum thicknesses will be met and things like that. And the guidance that we have for your orientation. So if you have 3D Sprint, when you go and do a quick design in your exocad, let's just grab something real quick. And everything you do, you click on, you'll see the NextNet materials. So your dentures and your splints and a couple of other things in there as well. So if you launch 3D Sprint from here, it will actually orient them. It'll put them out in the same orientation. It will choose the material for you, so you won't have to do that. And then you won't have to move things around. Now you can also grab these 2 files that have the yellow around them. That means they're not watertight. Perhaps they were like a save scene as, or they were going to be milled, and so they were not optimized for 3D printing. No big deal. You don't have to use Mesh Mixer. You can just use Sprint, so you don't have to keep incorporating more programs into your workflows, which is really nice.
Hey, Adrienne, real quick. I think we're still looking at your exocad screen here.
Oh, thank you.
Yep.
Hey.
It's funny, you can't, I guess I would need to share my entire screen. Okay, so we're in Sprint and you see the yellow. I've taken it into the prepare screen and I'm gonna hit fix. And this will just make them watertight, ready to print. No matter what you're doing, I think Matt, you have designed a diagnostic and you used the save scene as well, I think. So all I had to do here was I fixed the model, and in fact, I exported it. Maybe we can do another webinar or something, because I would really like to show like making a splint over it and a matrix. But you can just export it right out of 3D Sprint here and bring it back into your exocad if you need to. And if you guys are 3Shape users, you can also use this to prepare your files and then export them back into 3Shape, because I know 3Shape hates holes and stuff like that. So,
Adrienne,
so
if I may real quick, the temporaries we got from you,
yes.
we actually light cure glazed one set, and the other set we pumiced and high shined without the light cure glaze, and they are literally identical.
Oh, wow. Very cool.
It high shined up really nice, even without a glaze on.
Yeah, you know what? The printer puts out some beautiful surface texture. I mean, it is really, really smooth, and you can barely tell a lot of them are printed. So you'll want to make sure your margins are facing up and that your screw channels are facing as vertical as possible. And I apologize if this is a review of yesterday. I thought it was more applicable than doing models because they're so straightforward. And I'm going to orient the denture here at an angle. So this way, if there's any undercuts and things like that, there's no suction happening in here. And we tend to get the best accuracy on the top of it and the lower, on the bottom of it as well, if you orient it like this. But everything else is going to go and stay just the way you see it here. And I like to actually, if something's implant based or over a bar, I'm gonna go ahead and put a bar here just to maintain that cross arch accuracy. And so you'll just hit create bars and apply. You can see they're really easy to cut off as well.
Very good.
Okay, so hit your smart support. And we don't need to combine anything. If we were overlapping and making stacks of things, we would. That way the supports wouldn't go through each other. It creates supports. You can rest easy with these, with this program. It knows where to put the supports to get this material to print as accurately as possible. And you can see they're real thin tipped. And Matt, I did not recontour any of those. So you can see that the supports are so thin.
Very impressive.
Let me just add this real quick here. I'm just going to add a couple where there's no support, just to give it that little extra. And I'm going to hit add to queue. Now it's going to send it over to the queue. It happens simultaneously. I mean, if your internet is really fast, it happens within like 10 seconds. If it's slower or you don't have as much, then you're going to have, and you can see I have a lot of jobs lined up, but you might have a 30-second delay when it's slicing. And I have 3 printers in here. So in order to not get too distracted from Matt's workflow, Matt, I'll send it back over to you and then I'll start the printer with everybody to end it.
Sounds good.
Go ahead.
All right, here we go. Okay, so now we have our palletless conversion denture. And if you're not going to use tie bases and you're going to use cylinders, long cylinders, I would not have altered my screw hole placement, so just kind of keep that in mind. And if this is going to be my conversion denture, I just leave it as is. And then I'll show you here in a second. I'm going to switch those off. So remember, the only one I angled was number 6. So we can kind of go through this as normal. So this is going to be one of our conversions dentures. I don't use tie bases. I use the taller cylinders. That way I can get it as tall as possible in there for the most part. And so these holes end up being pretty tiny. And I want a little room just in case the implants don't end up exactly where we planned, just as a precaution. So I'll go in here to freeform the merge construction. You can do that after everything's been merged and saved. That's when you can cut holes and stuff. So hopefully this should only take a second. There we go. Okay, so from here you have your merge construction. I'm going to get rid of my minimal thickness so I don't see it in there. You go to attachments. We're going to do subtract, parametric extrusion, allow any changes. Go to circular, make that thing as tall as you want. Here, just drop it in, maybe. Here. What I like to do with this is I'll bring up my screw channels here, get rid of my merged so I can actually see those screw channels. And then I'll come over here, angle it the same as the screw channel. For the most part, bring up my merged, make sure I'm all the way through it. Once you're all the way through it, you just click apply. And Now I have a much bigger hole. So depending on what cylinders you use, you can come in here and always modify and make your holes bigger. Or if they're not big enough in your chair side, you just stick a burr in there and grind on it. That one's not going to go all the way through. But you guys get the gist of it. Basically drop your cylinder on here, make sure it's going all the way through, hit apply. And now you have a bigger hole. Okay? Simple as that. So you can leave it the small ones for the screw or make them bigger for cylinders. It does not matter. And then that will be the end of that restoration. Yes. And let me, you're done. It'll save everything. Let me get to you guys wherever you may be. I'd like to show you guys. Where are y'all? There we are. I was going to show you guys using my camera some of these pictures, but I can't quite figure out how to.
Well, maybe we can switch over to Adrienne. Adrienne, do you have a couple more things to show us here?
Yes, I do, actually. Up to you guys.
Go ahead.
Or Matt. Yeah? Okay.
It's all you.
Okay. I don't need to share my screen. I'm just going to, Matt, if you turn off your camera, I think I'll pop up.
Yeah, you're looking good there.
Thank you.
No, not you.
Oh.
Let's see. All right, cool. So what I'm going to do is I'm going to start the printer now. So it's all over here to the at the printer, and you can't really see the screen because of the light. But the print I just set up is an hour, and I have already printed it a few minutes ago. It only took 3 minutes. No, I'm just kidding. So anyway, this is the build is done. So we're going to clean that up real quick, and we're going to start our new one. And what I have here is I have my mixer and everything, but I'm going to use this cookie sheet. I found that it's really easy to put some foil on, and you'll be able to clean everything easier when your printer isn't right next to your cleaning area. So I also have a mixer or a stir. And so what you need to do is when you're using ceramic filled resins, what you want to always do, and any kind of filled resins, but especially Crown & Bridge MFH has ceramic in it, and that tends to settle. So you're going to want to stir that in the tray. And you only use 1 or 2 shades, then no problem. You don't need to empty your tray constantly. You can actually leave it in the printer and it won't hurt a thing. So, and if you do want to use more materials, more variety, because we have a ton of them, you can actually clean out your tray within about 2 minutes. I have a video on YouTube showing you how to do that, and we have a user manual as well. But you can use 1 tray for every material if you want. I prefer to have a couple of trays. This way I don't have to clean my tray, and I have the material ready to use. Now, if you do use Crown & Bridge MFH in any other printer or this printer, you'll want to make sure that you do stir it every single day or every 2 days, because it does settle, like I said, and you don't want to have to spend time stirring for 20 minutes. It's much faster to stir every day. So I keep my trays in an easy to access area. So you can see here that I have like a little drawer for everything. I have them labeled, so I can open them up, stir them, and then close them back up. So if you're always using like a light shade, like bleach, and then like a medium shade in 1.5 or something like that. So the next thing that you're going to do is put your build platform in. We're ready to start. It's all magnetic. You can do this one-handed. You start your printer, okay, and then you're going to scan your bottle. So you just grab that bottle, scan the back barcode, say that you've stirred it, you've cleaned it, and it's ready to go. Now you don't need much resin, which I like about that. So when you start to get low, you can print with as little as 50 grams in the bottom of it and keep going. And that first line is enough for 6 orthodontic models. Now, one of the other things is I've printed some models as well. I was going to show you a couple tricks about diagnostic models because you can have a nice polished looking model. So since there are holes in the build platform, you can just lean that up and let all of the residual drip down with any type of print that you have. And I use the soft Sedonic build for this. I want to be able to polish it with my hand piece, or I want to be able to just, I'm going to throw some resin on there. I'll show you how. But I'm going to carry you guys over to the cleaning station and just show you my setup real quick. We're not going to go through the whole process, but I want you to see what it's like to remove builds from that build plate. And this thing, if you have some nice, easy, thin supports like we use on ours, you're able to just pull them off. So my setup here is as follows. I have this Tupperware container with our stand, and this helps for easy punching when you go to clean your tray. I have an ultrasonic. This is everything you need to be set up. I have 2 beakers. You can use smaller beakers if you want to use less alcohol. You always want to use 91% alcohol on your next step materials. That will keep it from having any white residual resin after drying. And it'll also give a nice clean part in 5 minutes. So you're just going to pull off, and you can see how easy it is to pull these models off. And that's why Matt doesn't see a lot of scarring at all, because you see how fine tipped this is. So you just rub off those supports, and you'll put it in a dirty IPA bath. You can keep using it. Now, if you have bleach or white material, you don't want to put it in something that you've already used, like cast or something that's a little more like a different discolor. You don't want to add discoloration to your bleach colors, okay? So you can see that all you have to do is just kind of rub those supports off, and they just come right off. They're very fine tipped, and if you have the printer, you know. Now, if you have something that's fragile, you can always use your punch tool and punch it out as well, okay? So
hey,
what I do is—
real quick here for the audience, somebody was asking, you mentioned a minimum of 91%, but what if you use a higher concentration, 95 or 99%? Any with that?
So you can actually, what you'll want to do is you'll just add a little bit of water in there. So depending on what it is, offset it with that water. So then you don't have that white residue. So then after you do that, just put everything, don't mix, like, so if I was doing model peach or something like that, I wouldn't put my bleach MFH in there, okay? So you can see, I'm just gonna pull these off, and you can see how easy these pull off. Now, if they don't all pull off, that's okay. And if you don't clean it right away, they're gonna get harder to pull off because they're gonna continue to cure, right? But I like to have some fingernail clippers or some snips, some very like little fine tip. And then you can just actually snip those right off after you clean the parts in alcohol. And then you don't have to recontour, which is really quite convenient. So you put those in your dirty alcohol for 3 minutes, and then you're gonna transfer it over to 2 minutes. Now, if you leave it in there, you might end up getting some of your parts to be, it might start eating it away. So it's really important that you don't go for longer because you think it might get cleaner, it won't. If you find that they're not actually being cleaned well, flip them maybe halfway. So that way, maybe you're just not getting enough agitation. There's no need to brush it. Okay, these parts have gone through their clean bath. So I'm just gonna pull those out. And when you let your parts dry, you can use canned air. I mean, not canned air, excuse me, compressed air. But when you let your parts dry, you can see here that I have all of my parts kind of leaned up like this, and they'll dry much faster. Now, if you're doing your surgical guide, like all of these parts here are from this case. And you don't necessarily have to have all of these models. If you're confident with your CTs and your virtual articulator and your face scan, I know people that are doing this without models. So you don't necessarily have to have all of these models. These are just different scenarios. So something I like to do is after everything dries, and again, it's very important that you dry. If you are to post-cure a surgical guide and it's not completely dried, or a splint, or anything, your MFH, you could cause microfractures that you don't even see. And so you'll drop it and you'll say, why did it break? It's because that alcohol was boiling in there when you had put it in your oven. Okay, so you caused microfractures. Now, a little trick that I like to do if I don't want to polish, now you can see I use prosthodontic build. I've got a nice smooth surface, but you could always use a little bit of your model material before you post cure it, okay? And so I'm just gonna pour some in the cap here. But I have also, like for my dentures bonding, I have a little container. And so you could do that too. Just make sure it's mixed. And so before I put it in my oven, I don't recommend doing this for any biocompatible parts, but I'm just gonna brush a little resin here, nice thin layer. And then when it comes out, it's gonna be super shiny and I don't have to polish it before I make my matrix or send it to the doctor. Like a lot of times, you know, on your traditional wax ups, you would use floor wax or something like that. You can just put a little bit of resin on there. And I've already cured mine. So, you know, you'll put all your parts in here, 10 minutes for models. We have another chart. And I would say even if you're using a different printer, but you're using next set material, still go to our website, use this chart. You'll have great success if you do that, okay? So if you're having problems with the next set material, chances are it's probably because you're not following the instructions for use from the website. So it's not only for your next set printer, okay? It's also for next set materials. So you'll put that in for 10 minutes and then you'll have a nice shiny model ready to do your matrix. If you want to print a matrix, say you're not using models, then you can use this IDT. Just make sure you use a separator before you temp. You'll also, I've got a bite splint, so if you're going to do a night guard as well. And then I wanted to go over, and we don't have a ton of time about that, but I did want to go over the changes in a surgical guide, and I have some images, and since we're kind of out of time, we tried to cram a little too much here. I'm going to make a PDF of my presentation, and I'll drop it in the chat or give it to Neil. But something that you can do is put your sleeves in prior to your post-cure, and you'll have a better grip, and you can even use some resin as a glaze. You're going to see that when it prints, it's like this neon yellow. Okay, when it comes out first, it's clear. Then you clean it, it turns foggy neon yellow. After post-cure, it turns an orange color. Okay, and then after sterilization, it turns back to a nice clear color. Okay, so that is that. And I'm going to, again, I have a presentation for you guys about price per part, how long it takes to print everything, the ongoing fees and stuff like that. But mainly like price per part is something that everybody's really interested about, and how long does it take to print. So I'm going to show you, or I'm going to drop that presentation into the chat, and I'm going to let Matt show you the characterization and what he's done, because I think that's really important. I also have some more images on the presentation. So I will pass that all on to you guys, not take too much more of your time, okay? So.
Beautiful. Thanks, Adrienne. And while we're switching over to Matt here, one of the audience members was wondering, when you used the print resin and you were brushing it on, were you using that as a glaze, or what was the process again that you were doing there?
Yeah, so what I wanted to do was, instead of using floor wax or polishing it, I wanted to get a glaze on there, just so it's a nice presentation. You could even put a little pink if you wanted to, but I think it works out as a glaze. Not a biocompatible glaze though, so don't put it on your MFH before you put it in the mouth. It's just a diagnostic.
Gotcha. So just something to give a little bit of shine to those diagnostic models.
Yep, exactly.
Nice. Matt, are you ready to show us kind of the finished result there?
I am, as long as I can figure that part out. So I should just be able to hold these up to the camera and you guys can see what's
Yeah, show us what you did there.
All right, so let's talk about like their try-in material. We do a lot of denture try-ins digitally. And so what I do is I'll do the bases at 1.4 like I was showing you before. And we'll actually put some pink wax on it, just a little bit. Each doctor is different. We've had some that are okay with the denture try-in being all one color. But then the patients are like, well, that's weird. It doesn't look right, because it's different than what people are used to seeing. So we started doing the pink. We'll put a little pink on some of them for the guys that recommend it. And then we had the concern, well, that's not the real shade that the teeth are going to be. So in order to wrestle that, what we did is, if we're feeling pretty good about the bite, we'll go ahead and print the arch form of teeth in whatever tooth shade we're going to be doing. and then wax the denture in accordingly or traditionally as we normally would, so that the teeth is what they see is what they get. And that's all going to be by different doctors. Some don't care that it's all one color. Some want to see the pink. Some want the teeth, but you can do all options no matter what they do. For the, what do I got over here? Hannah, will you go see if there's something in that like your box? The temporaries, I know it's going to be hard to see. One is glazed, one is not. One's high polished, and I know that really is hard to see. But there is hardly any difference between these two. I would, if it's going to be a temporary, I would actually not send it to them glazed, but high shined, in case they have to adjust and grind, and then they go, well, how'd you get it that shiny or that whatever? They can always polish it. The conversion denture. So here is the conversion denture we did. We just used some triad pink around the facial and around the palate. And we use triad because it's just simple and it's in sheets, no other reason more than that. And then we have a nice aesthetic scenario to go in for the conversion. The surgical guide. Adrienne, I agree with you. When we do our surgical guides, we always put our sleeves in before they're cured. It makes for a much better fit and less adjustments, and your surgical guide fit your model absolutely perfect, and very nice. Very impressed with the print. What else we got over here? Custom trays. She has a custom tray material. When you're doing your all on fours and you're making those cases, we always like to have a custom tray, because you never know what's going to happen, and you may have to take an impression, and you may not be able to use the denture for that. So we pretty much always produce a custom tray to take with us on conversions for that matter.
Hey, Matt, here, quick question from Gus. What material do you use to bond the temporary cylinders to the printed conversion denture? And what material to glue the tie bases?
The tie bases, I use, this is interesting. So if I'm going to PMMA or print, I actually use the Gradia indirect composite and with a metal bonder. Metal bonder on the tie base side, acrylic bonder to the acrylic side, if you would. But using composite, it's a million times better than using the cement like we use on zirconia. On zirconia, we use the Ivoclar abutment cement, and that's fine for zirconia and everything. But anytime we're dealing with plastics and acrylics, I feel that the bond, as long as what you're bonding to has mechanical retention as well, those grooves around it, we get an excellent bond on those. The cylinders for conversions, I use, give me 1 second. We use the resin from Bredent, the Q resins, QU resin, self-curing, and we put it in syringes out of that container, and we'll use the syringes to lock them in. But the majority of our conversions, I don't actually bond the cylinders to the denture in the mouth. I do all of that in a sub lab. I use my conversion denture as a impression and also as a bite registration. So when I do that, I'm only in the patient's mouth for about 10 minutes, and then I can go to the sub lab and do all the conversion. And by using that conversion denture as an impression and a bite, and then I'll do everything on an articulator, I'm not back and forth in the patient's mouth, make that hole bigger, make it smaller. Is the bite right? Did you cut the cylinders too short, or are they too tall? It was much easier on the patient to only be in there for a few minutes, get the impression I need and the bite I need. I'm in the sub lab for, it takes about an hour and 25, hour, 35 minutes, depending. And then when we walk back in the room, we screw it in and the patient's done. So less stress on the patient. They've already been through enough stress. I have done a lot of conversions where we're doing it in the mouth, and I just found that the technique that is not mine, it's somebody else's and somebody else's and somebody else's kind of combined, that it's much easier to do that in a lab environment versus in the patient's mouth. But if we do have to lute the cylinders to the denture in the mouth, I use that Q resin from Breedent.
Beautiful. So at this point, I know we're running a little